Hi guys, welcome back to my channel. And today is the day 6 of DS bootcamp. And today morning I have explained GFG portal and have uploaded all the try run and examples. The name of the problem is the shortest path in a weighted undirected graph. I have explained the Dijkstra's algorithm and explained everything, visualization, everything. Please watch it. I will be attaching the description and solutions also C++ code, Java code, and Python code. All are and also JavaScript code also been explained there. Please watch it. And today I will be going with a lead code solution. This is a hard category and robot collisions. There are and one base index robots. There are and nothing but one number target number of an array, and which are one based robots, and each have a position on the line and the health and the movement direction, which means that they are given a position array and the health array and direction array. Each are lies on the same line, dotted line, the solid line. Okay, as you can see, and one based indexing the lines all the robots are placed over and their positions has been displayed here. For example, first robot was placed at 5. You can here you can check there. This is the first robot. Like that, it will be assigned, and the health is indicate that uh, respect to position, respect to robots have their health, maximum health. For example, fifth robot having the health of 2, and second robot having the health of 17, and third robot having the health of 15. And it was placed at the fifth index, one base, which are one base. That's what I'm saying. This is the fifth index, and the first robot was placed. First robot. This is the first robot, second robot, third robot, fourth robot, fifth robot. Okay, same. First robot placed at fifth index, index position. These are index position. Second robot placed at fourth index, and second robot placed. And respect to the weight, nothing but health. First robot placed at fifth index, and his health was 2. 2 was indicating, and second robot placed at fourth index, one base, as we can see, and is respect to 70. That's what the question, and none of the YouTuber has been explained there. I will be explaining in detail, and respect to direction. For example, first robot placed at the fifth index, as you can see, and his respect to health is 2, and his direction is rightwards. You can see. Second robot placed at fourth, and his health value is 17, as you can see, fourth position, and the second robot and his health is 70, and the direction is right. Similarly for all. That's what the question. And you can see that I will be explaining my drawboard so that I can draw and I can explain better. All are one based indexing, and also all are position on the line, and you are given a zero-based integer and array positions and health and the string direction, which indicates left and right, two possible characters. And all robots are start moving on the line simultaneously at the same speed in their given, whatever the given direction is given, the robots are start moving simultaneously at constant space. And if two robots ever share the same position while moving, they will collide. Whenever two robots are moving same direction, same position, when they are reached to the same position, which means the collision is happened, and it and there is a condition stating that whenever the collision occurs, the lower health is removed from the line, and the health of the other robot decreased by 1, which means that what whenever the collision happens, the lower health, for example, the outer robots we can see, these are collisions happens outer, and the lower health is the higher health is 15 and lower health is 12. So this is removed, as you can see, and this will be reduced by 1. The higher health will be reduced by 1. That's what the question states, that second robot which having the higher health will be decreased by 1, and the lower health will be removed from the line. And the same, we have to determine the health of the robots that are surveyed, still the collisions occurred, and the same order should be preserved, and we have to return that particular array itself. So the insertion order is preserved, and note also given, the position may not be sorted. Whatever the given position index one based indexing that are not sorted in nature. As we know that internally, whatever the Java or whatever, it starts from zero based indexing, but whatever the position indexings are one based. That's what the question states. Okay, this indicates the fifth position. You can see here the dotted lines starts from one base, and the position of the first robot at fifth position. So you should place the first robot at fifth position and its corresponding health. That's what the question. Same thing. This will be collide if the both having the same health. This will be removed off, and the lower health will be destroyed, and the higher order will be preserved. Same thing in lead code. There is one kind of a problem. Nothing but asteroid collision. The problem solution. It's also similar to that. This we have to maintain the order. That's the critical case. That's the reason they are kept as hard. And if everything is collide, you can see this case, everything is collide, same health. So we can return empty array. The constraint we should have to the into constraint are position length, health length, and directions. And will be reaching up to the 10 per 5, which is nothing but length, one like. And the position of I indicates and health. The position will be ranges to 10 power 9, and the directions are left and right. How we can decide the problem is easy, medium, hard based on the constraints only. You can see the constraints are reaching to 10 power 9, the health and positions, and the directions are reaching to 10 power 5. Whenever the maximum load and maximum we are keeping, the problem is difficult to solve in brute force approach. We have to optimize as much as possible to run in higher test cases, larger inputs. So while coming to the solution is very simple. We have to simulate the robot movements and handle the collision by step by step. With the help of stack, we can store the relative order, and we can store all the rightward direction robots in our stack. And whenever we encounter leftward the direction of the robot, we can pop out the least recently inserted robot from the right, so that it preserves the relative order, and we can check their health, and we can do the we can write a conditions like lower health will be destroyed and higher health will be -1. We can do, and we can check for the rest of the guys. So that is the main approach, and you can see the same thing has been explained here. And yeah, we have to sort the robots by their position, and we can simulate their potential collisions. Why we need to sort? Because if we don't sort, it was unordered, and we don't know unordered. We can't solve unordered mechanism. Either we have to sort in ascending order or in any organized way, so that we can come from one and two. We can left to right. We can go from left to right, so that it will be all robots will be cleared and all robots will be covered. You can see both the robots will be destroyed if the health is same. That's what the question states. And during that's pretty straightforward. I was explained, and let me explain the question. The code itself. We have the in the given question we have the positions, health, the direction. These are already been stated before, and have been explained the complete dry run here. I was taking an input position array. This is nothing but a position, and this is the index, and this is the health. Okay, health. And first of all, we have to take the position length. How many number of robots are there? That is the, and we have to take an index array. Why we are taking index array? Because of um, index array will store the, we have to sort based on the ascending order, and we have to sort their positions. So that's the reason we are taking an index array. We are simply starting from zero based till the number of robots we having, and add the respective index to it. Once we added that, we can sort the index array based on the comparator we are providing based on the position, their relative order, nothing but position relative order. We have to sort that. This having the integer dot compare method internally calls the object dot compare method, and it has two property. Minus one will be the comparison. When we compare the, we will get a minus one as a result, which means we have to that internally do the ascending order sorting. And whenever we found a positive comparison result, then it will do the descending order. And for zero, it will be both are equal and it will be stay as it is. Mm, this will be compared for both the indices like left hand side and right hand side. It will check for the respective positions and it will be sort accordingly. I can give an example, like this is the index array and I will be sorting based on the position. As you can see, which have the lowest position value, this is the 2, which having the index of 2. So this 2 is comes here, and the second least value is 3, which having the index of 0. So this is the place second. And third, we have the 5, the least one, and which having the index of 1. Same thing has been placed on the third variable. And the last one will be the 6, having the index of 3, that is stored here. So this is the sorted. After sorting, we have an this particular index array. On this index array, I will be iterating. I will traversing the one iteration and checking the respect to positions and direction and health. Here you can see adding the right moving robots to the stack. We have to add the right moving robots, but how we can check that? With the help of direction? We have the directions right on top, have been written direction, right, left, right, left. So position 2, it will be here, and the respective direction is right, R. So we have to add the particular index. We are adding the index. You can see current index, nothing but a 2 index, which health is 15. And similarly for 0, 0 is towards the right, and same thing will be added because of right, and this value is 10, health is 10. When we got a left index, nothing but one index, which is the left, and this will having an health of, you can see this health is here, the pointing towards 10. So this 10 will be here, and it going towards the left moving robots, and inside we have to pop it, and whenever we encode leftward, this condition, else condition block will be evaluated, and we are using while loop because until we reach the end of the destination, we will be doing the iteration. That's the reason we are using stack. If smaller elements we have, then we can delete all, we can destroy all the things when we have the left has a maximum. Okay, and we are popping the topmost and checking the health, which has the highest length. For example, here the case where top robot service because of its health is more, and the current robot will be destroyed because of its health is less. So you can see that top robot will be decreased by -1, and current robot will be set to 0, which means that destroy. And we are pushing that particular top because it is preserved their order. Similar thing will be happen for opposite case, vice versa. If both the robots having same health, both will be destroyed. That's what the question. And whenever we encode to left one, we are checking their health is equal to 10, and both are colliding operation. And here comes the case when we have the both the directions, like health condition, both the robots having the same, so both will be destroyed, all will be destroyed, and it will be popped up, and it will check for the second one. Second one will be 15, right? Whenever both will be destroyed, we are moving the current iteration. We are not doing any other operation. We are destroying both, and we are continuing with the other index, nothing but a 3. 3 having an health of 12, which going leftwards, and we have an inside of stack R. This is the left hand direction. This part else box will be evaluated, and the stack is not empty. We are popping out and checking which has the maximum health. As you can see, stack having the maximum health, and this will be destroyed. This will be destroyed, and this will be doing -1 for it. And at the end, we are getting a 14, and that 14 will be stored in the current index. The index value is 1, and at the end, number of indexes, number of health we have. that health index, the particular health index, we are updating that, and we are iterating throughout the length number of robots and checking whether health having the positive one, which is nothing but survival robots, that is added to my result and written back. That's what the question. Or else, if none of the having all are destroyed, then resultant array is empty. That's what the question stated. Time complexity is linear, and this will be executed only in worst case it will run twice only. One for the current iteration, second one for the second iteration in the worst case. So it is 2 into n, not n square. So the current and complexity and space is order of n, because we are storing an additional auxiliary space, right? For storing indexes and their respect to stack for direction, everything. Yeah, that's all about. Thank you. Please like, share, and subscribe. This problem has been explained. Yeah, sure. Thank you.